Have you ever stopped to think about the vast blue world that covers more than 70% of our planet? The oceans hold secrets older than time itself, mysteries buried deep beneath their waves. From supporting life on Earth to controlling the planet's climate, oceans are the most powerful force of nature. But here's the shocking part. They are in danger, and their decline could mean disaster for all of us. Welcome to Planet Earth, and today we take a deep dive into the world of oceans. Our story begins 4 billion years ago when Earth was a hellish, fiery planet. Picture a world covered in molten lava with constant volcanic eruptions spewing toxic gases into the atmosphere. The sky was filled with thick clouds of steam, and the surface temperature was so high that no liquid water could exist. But as the planet began to cool, something incredible happened. Water vapor from these eruptions started to condense, forming the first rain. And it wasn't just a drizzle. It rained for thousands, possibly millions of years, filling massive basins and forming the first primitive oceans. But where did all this water come from? Some scientists believe that icy comets and asteroids, which bombarded Earth during a period known as the Late Heavy Bombardment, carried vast amounts of frozen water. When these space rocks collided with Earth, the ice melted and added to the growing oceans. Another theory suggests that Earth's interior contained massive amounts of water, which gradually escaped through volcanic activity over millions of years. Over time, the oceans transformed from boiling, acidic pools into the life-supporting waters we know today. They played a key role in shaping Earth's atmosphere, helping to remove toxic carbon dioxide and eventually leading to the formation of an oxygen-rich environment. These waters became the cradle of life, where the first microscopic organisms evolved, life forms that would eventually give rise to all plants and animals on Earth. The oceans weren't just a result of Earth's formation. They became the foundation for everything that followed. The oceans are not just a giant water reservoir. They are Earth's thermostat. They absorb sunlight, distribute heat through ocean currents, and regulate temperatures across the globe. The process begins with solar heating, where the sun's rays warm the ocean's surface, creating temperature gradients that drive currents. These currents act as massive conveyor belts, moving warm and cold water across the planet, keeping climates stable and ecosystems thriving. One of the most famous ocean currents is the Gulf Stream, which carries warm water from the tropics up to Europe. Without it, places like London would experience much colder winters, similar to parts of Canada that are at the same latitude. But ocean currents don't just influence local weather, they shape the global climate. For example, El Niño and La Niña are major oceanic phenomena that can drastically affect weather patterns worldwide, leading to droughts, floods, hurricanes, and wildfires. When ocean currents change, the effects can be catastrophic. Scientists warn that if global warming continues at its current pace, the Atlantic meridional overturning circulation could slow down or even collapse. This would disrupt rainfall patterns in Africa and South America, accelerate ice melting in Greenland, and lead to more extreme winters in parts of Europe and North America. Some experts predict a scenario similar to the movie The Day After Tomorrow, where a sudden disruption in ocean currents triggers widespread climate chaos. But ocean currents don't just regulate temperature, they also drive nutrient cycling. The upwelling process brings nutrient-rich deep waters to the surface, feeding plankton, which serves as the foundation of the ocean food chain. Without upwelling, fisheries would collapse, affecting millions of people who depend on seafood for survival. The oceans also absorb carbon dioxide, acting as a carbon sink that slows down global warming. However, as CO2 levels rise, the oceans are becoming more acidic, threatening marine life, especially coral reefs and shell-forming organisms. Another way oceans influence life on Earth is through their role in the water cycle. Evaporation from the ocean fuels cloud formation, which leads to precipitation and helps maintain the planet's freshwater supply. Without oceans, rainfall would be scarce, causing widespread droughts and food shortages. In coastal areas, ocean temperatures also influence the frequency and intensity of storms. Warm waters fuel hurricanes and typhoons, making them stronger and more destructive. Climate change is already leading to more intense storms, rising sea levels, and increased coastal flooding, putting millions of people at risk. The vastness of the ocean is mind-blowing. Covering more than 70% of our planet, it is home to over 230,000 known species. But that's just the tip of the iceberg. Scientists estimate that over 80% of marine species remain undiscovered. That means that beneath the waves, there could be millions of creatures we have never seen before, living in habitats we can barely begin to comprehend. From microscopic plankton to the majestic blue whale, the largest animal ever to exist, marine biodiversity is staggering. Let's start with the most vibrant ecosystem in the ocean, coral reefs. Often called the rainforests of the sea, coral reefs are bustling underwater cities teeming with marine life. Just one reef can support more species per unit area than any other marine environment, providing food, shelter, and breeding grounds for fish, crustaceans, sea turtles, and countless other organisms. But here's the problem. Over 50% of coral reefs have already died due to ocean warming, pollution, and destructive fishing practices. Imagine a thriving metropolis turning into a ghost town. This is happening to reefs all over the world, and the consequences are devastating. Beyond the coral reefs, there are the open ocean and deep sea zones, where mysterious and bizarre life forms thrive. Have you ever heard of the goblin shark? It's a prehistoric-looking predator with an extendable jaw that snaps out to capture prey. What about the vampire squid, which can turn itself inside out to evade danger? And then there are bioluminescent creatures, organisms that produce their own light. Some use it to lure prey, others to confuse predators, and some, like the anglerfish, use a glowing lure to attract food in the darkness of the deep. The ocean also plays host to some of the most massive migrations on Earth. Every year, whales travel thousands of miles across the globe, navigating with astonishing precision. The Arctic tern, a seabird, undertakes the longest migration of any animal, flying from the Arctic to the Antarctic and back, a journey of about 70,000 kilometers every year. Marine biodiversity isn't just about strange creatures. It's essential for the survival of all life on Earth. Plankton, the tiniest life forms in the ocean, produce over 50% of the oxygen we breathe. They form the base of the food chain, feeding fish, whales, and even some of the largest sharks. But climate change and pollution are affecting plankton populations, and a decline in these organisms could have catastrophic effects on marine ecosystems and human life alike. But here's where things get even more alarming. The ocean is losing species faster than we can study them. Overfishing has already caused the collapse of many fish populations. For example, shark populations have declined by more than 70% in the last 50 years due to overfishing and the fin trade. Meanwhile, human activities have introduced harmful pollutants like plastic and chemicals, poisoning marine life and disturbing delicate food chains. The deepest part of our oceans, the Mariana Trench, is a place so extreme that only a few humans have ever visited. It's over 11,000 meters deep, which means you could fit Mount Everest inside it with room to spare. The pressure here is over 1,000 times greater than at sea level, enough to crush most submarines. Yet, against all odds, life thrives in these dark, high-pressure conditions. Deep-sea creatures have evolved some of the most bizarre adaptations known to science. The Dumbo octopus uses ear-like fins to fly through the water. The barrelly fish has a transparent head, allowing it to see in multiple directions. Some organisms rely on chemosynthesis, a process where bacteria extract energy from chemicals spewing out of hydrothermal vents instead of sunlight. These hydrothermal vents, often referred to as black smokers, release scalding hot water filled with minerals, creating entire ecosystems in the abyssal depths. Perhaps the most unsettling discovery of all? Plastic waste has been found even in the deepest parts of the ocean. In 2019, explorer Victor Vescovo descended into the Mariana Trench's Challenger Deep and found a plastic bag and candy wrappers lying on the seafloor. That's right. Our garbage has reached places we haven't even fully explored yet. This raises serious concerns about the extent of human impact on the planet. If plastic and pollutants can make it to the deepest corners of the ocean, what does that mean for marine life and global ecosystems? For thousands of years, humans have relied on the ocean for food, transportation, and trade. Today, 90% of global trade happens via oceans, with millions of cargo ships crossing the seas every day, carrying goods that fuel economies. But with great dependence comes great destruction. Our relentless exploitation of marine resources is pushing ocean ecosystems to the brink of collapse. From the earliest civilizations, oceans have been the lifeblood of trade and cultural exchange. Ancient maritime routes connected continents, allowing the exchange of spices, textiles, and knowledge. The Silk Road of the Sea, spanning from Asia to Europe, shaped global commerce for centuries. Even today, ocean trade remains vital, with megaships transporting oil, electronics, and raw materials across international waters. But the convenience of global shipping comes at an environmental cost. Massive cargo ships burn fossil fuels, emitting greenhouse gases and contributing to climate change. They also release ballast water, introducing invasive species into fragile marine ecosystems. Underwater noise pollution from ships disrupts marine life, especially whales and dolphins that rely on echolocation to navigate and hunt. The demand for seafood has skyrocketed, leading to unsustainable fishing practices. Overfishing has pushed many species to the brink of extinction. Once abundant populations of cod, tuna, and salmon have plummeted. The bluefin tuna, prized for sushi, has seen a 96% decline due to excessive harvesting. Fishing techniques like bottom trawling destroy ocean floors, wiping out entire habitats in minutes. Meanwhile, bycatch, the unintended capture of non-target species like dolphins and sea turtles, is killing marine life at alarming rates. Illegal, unregulated, and unreported IUU fishing further exacerbates the crisis, accounting for 1/5 of the world's fish catch. Without strict enforcement, entire marine ecosystems could collapse, leading to food insecurity for billions of people who rely on seafood as a primary protein source. Oceans are drowning in plastic waste. Every year, over 8 million tons of plastic enter the ocean, forming massive garbage patches like the Great Pacific Garbage Patch, which is now twice the size of Texas. Marine animals mistake plastic for food, leading to starvation and death. Microplastics, tiny plastic particles, have infiltrated the food chain, even appearing in the seafood we eat. The economic impact of plastic pollution is staggering. Coastal communities face declining tourism, fisheries suffer losses, and cleaning up plastic waste costs billions annually. Governments and organizations are pushing for bans on single-use plastics and investing in biodegradable alternatives, but the crisis is far from over. Climate change is accelerating sea level rise, putting coastal cities at risk. Jakarta, New York, and Miami are among the many cities experiencing frequent flooding due to rising tides. Small island nations face existential threats, with some like Kiribati and the Maldives preparing for complete submersion in the coming decades. Coastal erosion and saltwater intrusion are already affecting agriculture and drinking water supplies. Mangroves and wetlands, which act as natural buffers against storm surges, are being destroyed for urban development. Without urgent action, millions will be displaced, triggering climate refugees and economic instability. Let's talk about a crisis that affects all of us: ocean pollution. Every year, over 8 million tons of plastic enter our oceans. That's like dumping a garbage truck full of plastic into the sea every minute. The Great Pacific Garbage Patch, a floating mass of plastic waste, is now twice the size of Texas. Marine animals often mistake plastic for food, leading to mass deaths. But pollution isn't the only problem. Oceans absorb 30% of the CO2 we produce, making them more acidic. This process, known as ocean acidification, is slowly dissolving marine ecosystems, especially coral reefs. Coral bleaching, caused by rising sea temperatures and acidification, is turning once vibrant reefs into lifeless skeletons, disrupting entire marine food chains. Another devastating issue is oil spills. Every year, thousands of oil spills pollute our oceans, killing marine life and contaminating coastlines. The Deepwater Horizon disaster in 2010 released over 200 million gallons of crude oil into the Gulf of Mexico, causing massive environmental damage. Even smaller spills from ships and offshore drilling rigs release toxic chemicals that persist in the ecosystem for decades. Industrial waste and agricultural runoff also contribute to the crisis. Pesticides, heavy metals, and fertilizers wash into the ocean, creating dead zones, areas so depleted of oxygen that marine life cannot survive. The largest dead zone, located in the Gulf of Mexico, spans over 6,000 square miles due to excessive fertilizer runoff from the Mississippi River. The ocean acts as a buffer against climate change by absorbing excess heat. However, this is causing a dangerous rise in sea temperatures, leading to stronger hurricanes, disrupted fish migration patterns, and the collapse of marine ecosystems. Warmer waters are melting polar ice caps, accelerating sea level rise, and threatening coastal communities worldwide. The ocean isn't just a source of life. It's a vast, untapped reservoir of energy and opportunity. Covering more than 70% of Earth's surface, it holds immense potential to shape the future of human civilization. From clean energy solutions to deep-sea discoveries and futuristic oceanic habitats, the possibilities are endless. One of the most promising aspects of ocean utilization is energy production. Tidal and wave energy are emerging as reliable sources of clean, renewable power. Unlike solar and wind energy, which depend on weather conditions, tidal energy is predictable and constant. Countries like Scotland, Canada, and South Korea are already investing heavily in tidal energy farms, using underwater turbines to generate electricity from the natural movement of ocean currents. Additionally, ocean thermal energy conversion harnesses the temperature difference between warm surface waters and cold deep waters to produce electricity. This method could provide a sustainable energy source for tropical island nations, reducing their dependence on fossil fuels. Another innovative approach is salinity gradient power, which generates electricity by exploiting the difference in salt concentration between seawater and fresh water. Scientists are exploring this concept through osmotic power plants, which could revolutionize energy production in coastal regions. The deep ocean remains one of Earth's least explored regions, yet it holds the potential for groundbreaking scientific discoveries. More than 80% of the ocean remains unmapped, leaving room for countless unknown species and ecosystems. Biologists believe that marine organisms living in extreme conditions, such as hydrothermal vents and the Mariana Trench, could lead to medical breakthroughs. Deep-sea bacteria and fungi are being studied for their ability to produce new antibiotics and cancer treatments. In fact, some of today's most powerful painkillers, like ziconotide, are derived from marine life. Furthermore, the ocean depths could help scientists understand extraterrestrial life. Many of the extreme environments found on Earth's ocean floor resemble conditions on moons like Europa and Enceladus, which are believed to harbor subsurface oceans. Studying deep-sea ecosystems could provide insights into the search for alien life. With climate change threatening coastal communities, some scientists and engineers believe that floating cities could be the future of human civilization. These self-sustaining, eco-friendly ocean habitats could provide a solution to overpopulation and rising sea levels. Countries like the Netherlands and Japan are already experimenting with floating structures that can adapt to changing water levels. The Seasteading Institute, a pioneering organization, is developing plans for autonomous oceanic communities where people could live and work without being bound to any single nation. Additionally, underwater hotels and research stations are becoming more common, showcasing the potential for deeper human integration with the ocean. In the coming decades, we may see entire underwater cities powered by renewable energy and supported by sustainable marine farming. The deep sea holds vast amounts of rare minerals, including cobalt, manganese, and nickel, essential for modern technology such as smartphones and electric car batteries. Deep-sea mining companies are pushing to extract these valuable resources from the ocean floor, but environmentalists warn that it could cause irreversible damage to marine ecosystems. While deep-sea mining could reduce reliance on land-based mining, which often involves deforestation and habitat destruction, its impact on ocean biodiversity remains largely unknown. Scientists urge caution, calling for further research before large-scale extraction begins. The ocean is facing severe threats from human activity, including overfishing, pollution, and climate change. Plastic waste is creating massive garbage patches, while noise pollution disrupts marine life. However, marine conservation efforts, sustainable fishing practices, and climate initiatives are helping ecosystems recover, offering hope for the future. Innovations in ocean conservation, such as biodegradable plastics, green shipping, and large-scale cleanup projects, are gaining traction. Governments and organizations are expanding marine protected areas and promoting renewable energy to mitigate climate change's impact on oceans. Protecting marine life is not just an environmental concern, but but also essential for food security, climate stability, and economic sustainability. As the last great frontier, the ocean holds immense potential for energy production, medical discoveries, and even future human settlements. However, responsible exploration is crucial to preserving its delicate ecosystems. The choices we make today will determine whether future generations can benefit from the ocean's vast resources or witness its irreversible decline. There is still hope. Around the world, people are fighting to save our oceans. Conservationists, scientists, and activists are working tirelessly to reverse the damage caused by pollution, climate change, and overfishing. Innovative cleanup projects such as the Ocean Cleanup use autonomous systems to collect plastic from the sea before it breaks down into harmful microplastics. Meanwhile, researchers are developing biodegradable alternatives to plastic to reduce future waste. Governments and international organizations are stepping up efforts to protect marine biodiversity. Marine protected areas are being expanded, creating safe zones where fishing and industrial activities are restricted, allowing marine life to recover. Countries like Palau, Australia, and the Seychelles have led the way in establishing vast ocean sanctuaries. Studies show that MPAs not only revive ecosystems, but also boost fish populations, benefiting local communities and the fishing industry in the long run. Another promising development is the restoration of coral reefs. Scientists are experimenting with coral farming and transplantation, where corals are grown in nurseries and then replanted in degraded reef areas. Additionally, genetic engineering and selective breeding are being explored to create heat-resistant corals that can survive rising ocean temperatures. Even small changes by individuals can make a huge difference. Choosing sustainable seafood, reducing single-use plastics, and supporting eco-friendly brands can collectively help protect the oceans. Awareness campaigns and environmental education are also crucial. Schools and organizations around the world are teaching the next generation about the importance of marine conservation, inspiring future scientists and activists to continue this fight. The oceans have been here long before us, and they will be here long after. They have sustained life on Earth for billions of years, acting as the planet's life support system. But today, they face unprecedented threats due to human activities. Every piece of plastic we throw away, every fish we overconsume, and every oil spill we allow has consequences. The question is, will we act before it's too late? Will we choose to protect our oceans, or will we let them degrade beyond repair? The good news is that the choice is still ours. Science, technology, and collective action provide solutions, but they require urgent commitment from governments, businesses, and individuals alike. Imagine a future where oceans are free from plastic, marine species flourish, and coastal communities thrive. It is possible if we act now. The oceans have given us so much. It's time we give back. Let's ensure that future generations can enjoy their beauty, their resources, and their mysteries. Because when we save our oceans, we save ourselves. This was Planet Earth, bringing you stories that matter. If you found this video informative, make sure to like, share, and subscribe. Let's protect our oceans one step at a time. See you in the next one.